Hi everyone! Welcome back to another Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me tonight is a familiar face and one of the students that works at the Planetarium, and I'll let him introduce himself.
Hi, I'm Eli. I'm a physics undergraduate student at UMD.
So tonight we are going to go on a tour of the moons of the solar system, because we've definitely looked at the planets, but there are definitely some really cool moons out there as well. Some that are, I would dare say, more interesting than some of the planets. Before we get switched over to start our tour, if you do have any questions throughout the show, leave them down in the comments. And Eli will be watching those and will let me know when a question pops up. If we don't get to it right away, don't fear. We will take time at the end of the show and answer those questions that we didn't get to right away. So with that, let me get switched over. There we go. To our program. And after months, I finally figured out how to keep my video there. So we're going to try this out tonight and see how it goes with our operator, me, up there in the corner for you guys. All right, so we are starting out here at the Earth for many reasons. One of which is because the Earth, whoops, got a little tipsy there. There we go, is the first of the planets in our solar system that has a moon. Oops. Forgetting some of my commands here. There we go. So the program we're using tonight, I forgot to mention this, is a program called Celestia. It is a free program. There is a link in the description of the video if you'd like to check it out for yourself. And it's pretty simple to use. They also have some really good documentation on kind of how to use it and stuff. So we are going to head on over to Earth's companion, our moon. Now, as I had said, Earth is the first planet in our solar system to have a moon. Mercury and Venus do not. And our moon is pretty cool looking. You may notice it looks pretty similar to the planet Mercury, and there's a really good reason for that. They're both pretty similar objects. They're big balls of rock that have no atmosphere, and as you can see, have their surfaces absolutely covered in these impact scars. And part of that is because there is no atmosphere to burn up these bits before they reach the ground, so they get hit by everything. But then there's also the fact that the moon doesn't have erosion or plate tectonics or volcanoes or anything like that. And so once a crater is formed, it sticks around pretty much forever until another object hits and disturbs that crater. And so what we're seeing is really just the accumulation of impacts over the 4.6 billion years that our solar system has been around. You'll also notice that the surface of the moon is kind of two-toned. We have this lighter area that is really covered in craters. Just everywhere we look, completely saturated in craters. But then there's also this darker area that has a few craters, but doesn't seem to be quite as saturated. There don't seem to be quite as many in this dark area. And so this dark area of the moon is known as the lunar maria. Maria is Latin for sea, a body of water. And that comes from long ago, before we had telescopes, when people would look up at the moon in the sky and they saw these dark patches, they thought they looked like bodies of water, and so they thought that's what it was and named them the Maria, or the seas on the moon. Once we had telescopes and we could really zoom in and see the surface, we saw these craters and bumps and cracks and ridges and realized that this was a solid surface, not a liquid, but the name stuck, and so we still call it the Maria. But what these actually are ancient lava flows. So back early on in the history of the universe, even the moon itself was so hot that it was molten inside. And as it's getting hit over and over again, sometimes the surface got hit hard enough that it cracked open, and that molten rock was able to well up to the surface and spread over the surface. And it kind of repaved those areas, smoothing out the craters that were there, just like we kind of pave over potholes in our road. And so that destroyed the craters that were currently there and left behind this smooth, dark, solid surface once it had cooled and solidified. Now, today we don't see this active happening on the moon. It has cooled down. It is no longer molten inside. It is what we call geologically dead because there's just no heat inside to drive any sort of activity like that. All right. So we've had a nice good look at our moon. And now let's head on over to our next planet that has moons, and that is the planet Mars. So Mars is our red planet, and if you head out in the evening around, I think we saw it around midnight last night actually, you can see it up in the east. It actually does look red in color, which is really cool. But anyway, back to the moon's tour. So Mars has two moons. You can see them here, Phobos and Deimos. But these are kind of different than our moon. Oops. Sorry, trying to operate here. There we go. So we'll zoom on into Phobos here. And it looks not like our moon. I lovingly call Phobos and Deimos our lumpy space potatoes, because to me, that's what they look like. They are much smaller than the planets or our moon is. They are lumpy, irregular, covered in craters, and actually look an awful lot like asteroids. And it turns out there's a good reason for that, because we think Phobos and Deimos are both captured asteroids. And this makes sense, right? Mars is right on the edge of the asteroid belt. And so it's probably encountered quite a lot of them in its history, and it just happens that two of these asteroids were moving slow enough that Mars's gravity was able to grab onto them, and they started orbiting around Mars and became moons. And so our lumpy space potatoes here are former asteroids. And so here is Phobos, and again we see just lots of craters all over the place. And then we can also head over, oops, there we go, to Deimos, which looks pretty much like Phobos. All right, we got another lumpy space potato here. It looks a little bit smoother, and we think that's because Deimos is actually covered in a thick layer of kind of sand, and that is obscuring the view of some of those craters. It's kind of like filled in some of those craters and makes the surface look a bit smoother than Phobos. And we're not 100% sure why Deimos would have a thicker sand layer than Phobos. Maybe it's because Deimos is further out from Mars. And so this sand that's probably from a lot of impacts is more likely to collect on the moon rather than falling to Mars, whereas on Phobos, any debris that's kicked up is probably more likely to fall to Mars than get swept up by the little moon. And so that's a possibility as to why Phobos or Deimos has kind of a thicker dirt layer or sand layer there. All right, so we are going to leave our lumpy space potatoes and the inner solar system and head on out to the outer solar system with the largest planet, the king of the planets, Jupiter. And as we can see from all of these lines around Jupiter, it has quite a lot of moons. Current count puts the total number of moons for Jupiter at about 79. Now, most of these are lumpy space potatoes. So most of these are captured asteroids or maybe even captured comets that got a little bit too close. But there are 4 large moons around Jupiter, the 4 largest moons around Jupiter, that are quite interesting. And these are known as the Galilean moons because the astronomer Galileo was the first to discover them. And you can see them for yourself. If you have a big or decent pair of binoculars or a small telescope, like 4 to 6 inches, and you look at Jupiter, which can be seen up in the south right now at night, you can see 4 tiny little bright spots around Jupiter, which are those 4 Galilean moons. But we are going to start off with the innermost of these, which is the moon Io. Now, Io has, there we go. Io has its own kind of interesting nickname. We like to call it the pizza moon because, well, it kind of looks like a pizza, right? We have that yellow and white cheese. We got some spots where we got some red sauce poking out. We've got some darker specks that could be sausage, or Eli says olives, but I apparently started something last time I said that he was wrong. We'll just say it can be whatever pizza you want it to be. But what's really interesting about Io is all of these dark specks that we're seeing are actually volcanoes. Io has over 150 active volcanoes, which is crazy because Io is about the same size as our moon. And as we saw, our moon does not have any active volcanoes. It's geologically dead. And so, this was a big mystery. How can something the same size as our moon be so very different and so very active? And it turns out the answer is because Io is caught in this kind of tug of war between Jupiter and the other Galilean moons. And so Jupiter is on one side, tugging Io towards it. And then we have the other Galilean moons on the other side, tugging Io the other way. And so it's getting tugged back and forth, back and forth. And as it's being tugged back and forth, it's kind of getting stretched and compressed and stretched and compressed. And as it does that, the rocks start rubbing against each other. And just like to warm your hands up on a cool day, you rub them together, as those rocks rub back and forth, they heat up. And Io is being tugged back and forth so much and so strongly that that's heating up its interior so much that the only way for that heat to escape is through these hundreds of volcanoes that cover its surface, which is crazy. It's so active that if we zoom in real close, we only see volcanic craters. We don't see any impact craters because pretty much as soon as an impact crater is formed, it's covered by an eruption because eruptions are taking place all the time. So it's a crazy world. And that yellow color comes from the sulfur that's released from all of these volcanic eruptions. So I guess if we want to stick with our pizza analogy here, this would be a rotten egg pizza, which I think Eli will agree with me that does not sound pleasant. So maybe we'll make that our compromise.
I mean, if there are olives, I don't know, that could save it.
No, that would make it worse. I don't know what you're talking about. All right, let's head on from Io to the next of the Galilean moons. And this is the moon Europa. So if Io was our land of kind of volcanoes, Europa is our land of ice. And you can see here that the surface of Europa is covered in a thick layer of ice. And in some places it looks like maybe a giant's been ice skating across the surface. But what we're seeing here are actually cracks in the ice because Europa, like Io, is going through that similar tug-of-war process. And as it's being tugged back and forth, that kind of cracks the ice on the surface, but also heats up the interior. Not as much as Io, though, because it's further away, so this tugging back and forth isn't as strong. But what it does happen is the inside of Europa gets warm enough for that ice to melt. And liquid ice is liquid water. And so we think that underneath this icy crust sits a huge ocean of liquid water. And I mean huge. It's estimated that there's twice as much water in this ocean than there is on all of Earth combined, which is insane. And we are very excited about this possibility because one of the things that we are fairly certain life absolutely has to have to develop is liquid water. And so where there's a lot of it, there's the potential for life to have formed. And so we actually have future missions in the works right now to go and land on the surface of Europa, drill or melt its way through that icy crust, and then explore that ocean below and tell us what's there, which I'm very excited for. I hope it happens in my lifetime, but we'll see. That's definitely going to be an exciting day. All right, so heading off from Europa, we're going to head to the third Galilean moon, which is a Ganymede. And Ganymede is actually the largest of the Galilean moons and the largest moon in the solar system. It's actually bigger than the planet Mercury and about 3/4 the size of the planet Mars. It is a beast of a moon. And we can see its surface is also covered in ice, but we do see kind of craters and stuff. There's also some areas that have this kind of more rigid terrain to it, and these like darker patches. And in these lighter patches as well, you can see where maybe there were some cracks that allowed some water to well up and flood the surface. And so there might be a liquid ocean water beneath the crust here as well. But we're not as certain of that as we are with Europa. All right, and then the last of the Galilean moons, the outermost, is little Callisto. And Callisto is really just a big ball of rock and ice that's covered in craters. He doesn't have as much going on as, say, Io Europa, but he's still pretty cool to look at. And so there is our crater-covered ball of rock and ice. That is Callisto. All right, so moving on to our next planet is Saturn. And we can also see that Saturn has a lot of moons too. Saturn actually has more moons than Jupiter. Its current count is at 82. But just like Jupiter, most of these are the lumpy space potatoes. So asteroids or comets that got a little bit too close. But Saturn does have a few very interesting moons. And so we'll go start off with the largest of Saturn's moons, and that is the moon Titan. Now, Titan is the largest of Saturn's moons, but it is the second largest moon in the solar system, just behind Ganymede. So it is also larger than the planet Mercury, which is crazy. But Titan is special for another reason. As you can see this kind of fuzzy outline around it, Titan is the only moon that has a thick atmosphere. In fact, its atmosphere is thicker than the Earth's. It's so thick that we can't see through the clouds to see to its surface. It wasn't until the Cassini spacecraft got there to Saturn that it was able to use its infrared and radar imaging to peer through the clouds. But it also released a probe called the Huygens probe, which descended through the atmosphere and landed on the surface. And that allowed us to really see beneath those clouds that I have just removed. and see what the surface looks like. And what's really strange about Titan is it seems to be very active, and active in ways that we haven't seen on a moon so far. Because when we look closely, we can see areas, and it's a little bit hard to see on the computer, but we can see areas that look kind of like drainage networks, where liquid has kind of flowed downhill. But even more crazy, when we look at the poles, and here we go, we actually find lakes of liquid. Now, it's not liquid water, because it is far too cold out here for water to be a liquid. It is a solid. In fact, the surface of Titan is frozen water ice. And so this liquid that we're seeing on the surface is liquid methane. But it looks like Titan has a whole precipitation cycle with liquid methane like we have with liquid water. And it creates not only the lakes, but also these rivers that cut across the surface. There are areas of evidence of areas that may have had flash floods when there was a sudden downpour. It's a surprisingly familiar looking terrain, if just at very extreme temperatures and different, elements, different chemicals, rather than water, methane. But it gives us kind of, maybe not hope, but makes us wonder if life could develop in these conditions and could develop to rely on liquid methane rather than liquid water. And that is why we are sending another mission there. We will be sending Dragonfly, which is a quadcopter, because there's a thick atmosphere, we can fly around in it. And it's going to fly around Titan and get us more information and possibly search for evidence of even just single-cell organisms that may have developed on the surface, which is, again, going to be very exciting. All right, so there are, let's do two more of Saturn's moons that I want to show you. First up is Enceladus. And Enceladus is a lot like Jupiter's Europa. It is an icy surface. There are some cracks in the surface, but unlike with Europa, on Enceladus, especially these cracks here at the South Pole, we actually see jets of water vapor spewing from these cracks, which tells us that it is warmer inside and warm enough for there to be liquid water. And so just like Europa, we think that Enceladus has an ocean of liquid water underneath its surface. And that ocean is a little bit easier for us to study because of those jets that are, venting out that water from underneath the surface. We could just fly through those plumes and analyze what's being blasted out by the vents rather than having to drill through. And so it gives us a way of kind of a little bit easier studying, but we don't think this ocean is quite as big as Europa's, which is why we're still primarily focused on exploring Europa. And then the last one of Saturn's moons that I want to go visit is really just a fan favorite. It's the moon Mymus. And if I can orient it correctly, you may notice it has a very familiar looking shape to a science fiction spaceship. If you know what it is, type it down in the comments. But this is known as the Death Star moon because it looks like the Death Star. Now, this moon was actually discovered after the first movie came out, so it's a complete coincidence that they look alike, but it's always a fun one to show. All right, so let's head out to our next to last planet, the planet with the funny name, Uranus. And it has quite a few moons of its own, not as much as Jupiter and Saturn. I believe the count's at 27, might be 24. But it's somewhere in the mid-20s. Unfortunately, Uranus does not have as interesting of moons as Jupiter or Saturn do. Most of them are those lumpy space potatoes, or just big chunks of ice and rock that aren't really doing anything, kind of like Callisto, just big chunks of ice and rock that have just been around forever. And, but one of the cool things about Uranus's moons are they're all named after characters from the works of William Shakespeare or Alexander Pope. And so they're all these literary characters that they're named after. And my personal favorite of, oops, what happened? I don't know what's going on. Let's just go back here. Okay, sorry. Technical difficulties. We're getting it. Why is that? I don't want to go. Alright, well, let's just see if I can click on it and go. I wanted to show you Miranda, which I don't know how to get rid. I don't know what I pressed. Okay, did that work? Yes, okay. I have no idea what button I just pressed to make that happen. But I wanted to show you the little moon Miranda. It's one of the smaller of the moons, but it's the most interesting of them because its surface is covered in these kind of markings. You can see them well here. Some of them are kind of circular markings, and we were very unsure what was going on. At first, it looked like maybe Miranda was just this big rubble pile, and all of these little markings we were seeing are the outline of these big pieces that had kind of come together to form the moon. But now we actually think that these are chunks of the surface that have been kind of rotated over time. And we're not entirely sure the mechanism of how or why this has happened, but it turns out to be this very strange moon that we're still trying to figure out what's going on. Unfortunately, anything with the planets Uranus and Neptune we have not studied as well, simply because they're so far away that we can't study them well from here on Earth. And we've only had the one spacecraft, Voyager 2, which flew past in the late 1980s. And so our information about these planets and the moons around them are very slim. But the last of our planets is Neptune. Neptune has a little bit fewer moons than Uranus. I think it's about 17. But it does have one really interesting one, which is the moon named Triton. Not to be confused with Saturn's Titan. But with Triton, we can see a lot of kind of texture on its surface and a lot of what seems to have been some sort of geological activity, which we're still trying to figure out. But it also has this area called the cantaloupe terrain because the surface looks like the surface of a cantaloupe. But what's really weird about Triton is it's the only moon, or only large moon, that orbits around its planet in the opposite direction that the planet spins. So all of the other large moons that we have seen today, they all orbit their planet in the same direction the planet spins. And that's a consequence of how everything formed. But Triton doesn't do that. And so we think that Triton is the only large moon that was actually captured by the planet. And so we think Triton used to be a Kuiper belt object, which is like the asteroid belt, but for icy debris out past Neptune. Pluto, for example, is a Kuiper belt object. And so we think that Triton started out in the Kuiper belt and then got a little bit too close to Neptune, and Neptune captured it. And what's exciting about this is it allows us to study Kuiper belt objects a little bit easier because we don't have to go as far to get to it as we do other objects out in the Kuiper Belt. So it lets us kind of study what's going on there, and also confirms that, like Pluto and a few other larger Kuiper Belt objects we found, that there were quite a few of these larger icy objects out there. And now most of these larger objects in the Kuiper Belt are known as dwarf planets. But with that, we are finished with our tour of the moons of the solar system. So we are going to head on back home, and I will switch back over. And yeah, those are just a few of the many, many moons in our solar system, but there are some really interesting ones out there, and a lot of mysteries still yet to be solved, which is exciting. It's one of the great things about astronomy is there's still a lot to learn, and new discoveries are made every day, which makes it fun to teach, because I get to be a student constantly, which is great, because I like that. But yeah, so Eli, did we end up with any questions?
Nope, nothing this time.
No? All right, well, if you do have any questions, now is a great time to leave them down in the comments. And I will also, while we're waiting, tell you a little bit about what's going on over the next week. So Saturday, Eli is going to be doing Astronomy Fact or Fiction, which is looking at all sorts of kind of ideas and possibly some misconceptions that people typically have, and kind of exploring whether they're right or wrong and things like that, which I'm excited for. It's looking really great. This is actually a revamp of a show that we used to have called Mythbusters Astronomy, and we're just kind of updating it and making it look a little bit better. And that will be hopefully ready to go for you guys once in the planetarium, once we can safely reopen. And then next week on Wednesday, we are doing an adventure through the universe, where we're going to take you to really as much as we can see of what's in the universe in 30 minutes. And then on Saturday, Lindsay is going to delight us with furry physics and kind of show us how animals and insects use physics every day to do things like navigate. It's really cool. There's a lot of awesome stuff in there. And then coming up in a couple weeks, the week of August 24th, we are going to be launching our virtual dark sky caravan. Some of you may know that for the past 2 years in the summer, we have taken our portable planetarium up the North Shore and had a week of shows and telescope viewing and lots of fun. Unfortunately, with the pandemic this year, that is not going to be able to happen, but we still want to celebrate, and so we're going to do it virtually. So we're going to have a week of shows, and we're going to have guests from local partners that are also going to join us. And then if it is clear that night, we will also be live streaming views through the telescope so that you can get close-up views of the moon, Jupiter, and Saturn, and maybe Mars, maybe some other stuff. We'll see what's up that night and what's visible. So that is coming up the week of August 24th. And we are sad that it has to, be different, but also excited to still get to celebrate our wonderful dark skies that we have up here. So with that, unless we've had anything else come in. All right. Well, thank you everyone for joining us. If you'd like to see any of our past shows, you can find them on our YouTube channel or in the video section of our Facebook page. But we hope you have a wonderful night, a wonderful rest of your week, and we will see you next time. Bye, everyone.